So the next example that we would like to discuss here, how to do inverse for not one-to-one functions, because earlier we do inverse for one-to-one function. Sorry, I guess it shouldn't be f, but it should be v inverse. Okay, so for example, we have function fx x squared. So what will be the inverse functions here for f functions? So for this one, definitely you should refresh again your memory about exponential, because it will be used a lot in here. Some of the properties can write it down in here for you to remembering back. For example, a to the power of m times a to the power of n, that will be m plus n, or a to the power of m divide a to the power of n, that will be m minus n, or m and like this, that will be m times n, or like this, that will be minus if you put or bring up, and the other way around, if you bring it down, that will be minus, or the signs will be changed. This is some of the properties that you should remember. Or for examples, again, if you have like a to the power of m and then square n, that will be m divided by n, like that. So for example, 3, if you put this into exponential, that will be 3. What is this power 1? Because it's not written, over this is always 2 because it's not written. So means if you have like that, so you will have like this, because 1 and 2 will not be written. If you have 4 here, 5 here, that will be 3, 4, 5, like that, to the power of 4, 5. So these basic exponentials, I don't want to discuss further. You should already know, because as I said, for not one-to-one function, this property will use a lot in the process. Okay, so for example, let's see, just hit the first example here, fx equal to x squared. So what will be the inverse? The process will be the same, it's not going to change. The first thing that we need to write down is the statement that fx equal to y. So our fx here, x squared, and then y into. We need x, but over here we have x squared. So how are we going to remove or dissolve the x squared over there? Of course, by multiplying again with 1 over 2. So x over 2 multiply with 1 over 2. Because the left side you power by 1 over 2, the other side also must be the same, like that, to make it balance. The value will not be changed. So here, as mentioned, according to the exponential rule, that will leave us with x to the power of 2 times 1 over 2. Over here, 1 over 2, like this. This one can cross, so we left with power 1. So we have now left with x, y, 1 over 2. Then 1 over 2, y to the power 1 over 2 here is just the same like we already saw the examples here. so that will be square, right? So x y square, like that. So finish the separation, finish, make it x become individual or single axial finish. So you can give name or just use the notations inverse is to the power of square root of x, like that. So again, this is the original function, fx equal to x squared. The inverse become f inverse x is square root of x. We can try the original functions fx x squared. So if we try any number f4, so 4 squared, that will be 16. Now we try to bring back this number to the origin using the inverse function. So meaning f inverse function 16. The inverse function is square 16. 16 square, you know it already, is 4. Voila, you get over there. Okay. So regardless the function is one-to-one function or not one-to-one functions, the process will start the same as it is, as you see earlier. Start with this statement, and then the manipulation process starting from here to here, separating x until you find x in a single mode like this. Then you give a name or just notation of inverse. Okay, you're going to see one more examples after this video.